Hi, my students. Here we are inside of my bathroom, not just because I've been filming myself in random various places all over my house recently, but because there's something I want to show you really quick, and that is a little demonstration with light. Light is a really interesting thing, and it's crucial for you to understand some of these characteristics about light before we can actually move on to helping you understand other parts about this next learning goal having to do with redshift and understanding evidence for the Big Bang and things of that nature. So here's what I wanted to show you. Here, we're actually in here because I needed some good lighting. And turns out in my bathroom there's some good lights right here. Alright, so here's some lighting. When you look at this, what color do you see?
I don't really see any color, Mr. Stevenson.
Very good. So you see basically white. And if you don't see white, come on now, that's white. So there's some white right here. But now here's the other thing that we're going to do though. We're going to take this little lens right here and I'm going to put it over the lens of my camera, and I want you to see what this lens does to that light. Sorry. Earthquake. So here we go. So here is that light, but now I'm going to take my little lens, I'm going to put it over my camera lens. Ding! And voila. So as you can tell, what you are now seeing is that white light, there's more to it than what you actually see. What this little lens does, this acts very much like a prism. This is taking the light from those light bulbs and it's unpacking it, because that light is not just one color, it's not white, it's actually a package of all of the different colors. So when you split the light up, when you unpack it, what you're actually seeing are all of these different colors. But now, why do we actually see different colors? What makes red versus blue versus green or yellow? Well, it has to do with something called the electromagnetic spectrum. That's a very long word that you don't need to have memorized. It's good to know, but let me just show you rather what it's referring to. Alright, this is my wonderful example of what the electromagnetic spectrum looks like. What this is looking at is this is showing you all of the different types of light that there are and what makes them different. So first of all, what I wanted to point out is that when we talk about light, sometimes we're just referring to this part right here. This part of the spectrum that all of us see. And since it's the part of the spectrum that we can see, this part is referred to as the visible part of the spectrum, because your eyes and my eyes, we can see this part of the spectrum. Other parts of the spectrum, though, that we can see, but that are still a type of light, are things like radio waves, or things like X-rays. When you get an X-ray, you're basically just being blasted with a certain type of light. You don't see it though, because that is outside of the part of the spectrum that you and I can actually see. You and I can't see radio waves, but if we could see them buzzing all around us, and that would probably look really cool, but they are still a type of light wave. All right, so what is the difference? How would I make a cell phone wave versus a radar wave, or a radio wave versus visible light versus an X-ray? What is the difference between all of these? If you can't see already, here is the difference. All of these waves travel in a wavelength, meaning the length of the wave that makes each one of these what they are is a very specific length. Now, to go from here to there, you don't need to change anything other than how far apart the wavelengths are. If I take a radio wave, and if I make it shorter and shorter and shorter and shorter and shorter and shorter, I could turn that radio wave into visible light. Likewise, if I could take visible light, and if I could make it longer, I could take that wave, and I could make it a sound wave. Cool, isn't it? So that's the first thing I need you to understand. One, that light is just one part of a very broad spectrum of wavelengths of light. The second thing I need you to understand is that to change the type of light you have, all you have to do is change the wavelength. So to go from red to purple, the only thing you change is how long the wavelength is. So if I make the wavelength shorter, then I will move towards this end of the spectrum. However, if I make the wavelength longer, it's hard to keep those straight. If I keep the wavelength longer, then I'm actually going to end up moving towards this side of the spectrum. So these are longer wavelengths. These are shorter wavelengths. The only difference between these colors is literally just how long the wavelength is. There's not a specific green wavelength that has any other characteristics other than it has a certain wavelength. If I change its wavelength just a little bit, it'll change to a different color. So those are the two things to understand. All of these are just a type of light, and that to change the type of light you have, whether it's one of these or even if it's a color, all you change is your wavelength. Shorter wavelengths, more over here. Longer wavelengths, more over here. Okay, so why does that matter? Well, to show you why that matters, I need to take you into another certain room. My toilet room. Don't worry, this should be fine. I'll turn on the fan. Well, it's official. I'm officially teaching a lesson on the toilet. But anyway, this is just one of the only places in my house where I could actually find a really dark space, and I need to find a really, really dark space. This is just one of the places, so we're gonna work on it. All right, here's what we're gonna do. What I have is I have some special little tubes right here that I wanna show you. Bling. Okay, so inside of these little tubes, and I have a couple of these, this is just one example. Inside one of these little tubes are just one single element. This particular tube is filled with the element neon. So there is nothing else in this tube. It's been vacuum sealed with just neon. Now, what they have done is that they have hooked up just a few little electronic prongs that go into each side here. And what I'm going to do is I'm going to take this tube, and I'm going to hook it into this weird little guy. What this is going to do is I'm just going to turn it on, and it's basically going to start energizing each one of these little particles. And what that does, I'll just show you here. Ding. So all it does, makes a bright little light right there, right? Now, this light, like the light that I had over my vanity right over here, this is actually a package. Right now, you're seeing one particular color. You're seeing like this beautiful orange color, but this beautiful orange color is a certain little package. So I wanted to actually show you what this looks like. Okay, so here is this light. Again, just when you are looking at it normal without anything else. But now what I'm gonna actually do is I'm going to take our little lens right here, and I'm going to put it over my camera lens, and I want you to actually look at what you see around here. Ooh, Okay, so now what I actually wanted to point out really quick here, you see off to the side here, so like right here, this is actually what I really want you to be paying attention to, this, or this over here. Okay? These little lines right there are the unpackaged light of this element. Now, what you can't really see too well on the camera, but what actually is visible when you look at it with your own naked eye here, is that in this little line, these little barcode patterns, there's actually like a really brilliant green line right on the end here, and then a bunch of orange and yellows. Now, here's why I'm showing you this. No other element, when you heat it up like this, when you make it emit light like this, will actually show this same pattern of lines. Those patterns of lines are very unique to neon. They're like a barcode, really. So when we see that pattern of lines, let's say I was a totally colorblind person. I couldn't see any colors at all. But if you showed me that pattern of lines, I could line that pattern of lines up and I could actually identify just with those lines that I'm looking at neon. Okay, let's compare. So here is neon. Now let's compare and look at some others. Whoa, radical man. Alright, so this next one that we have right here, this is the element argon. So it has a beautiful pattern. What it actually looks like in real life is that this is actually like this really beautiful purple color. I know on the screen right there it looked more blue, but it's actually this really kind of brilliant pink purpley color. Pretty awesome. Right, so this is what argon looks like when you are just looking at it normally. But again, let's put our little lens over it here and let's see what you see. Whoa, so beautiful. Now, it's really, really hard to tell, but you can actually see that this barcode pattern is just a whole lot of different ones. There's actually a wide range of different colors that are actually in this one. So if you look, I know you can't really see my hand, but if you look really closely around over in here, you actually can see reds, oranges, yellows, and again, it's in this very distinct pattern. There's a specific number of yellow lines, a specific number of red lines. Their spacing between them is very specific. And again, all of this is just because each one of those lines has their own particular wavelength. So each one of those is very characteristic of a specific wavelength of green, a very specific wavelength of yellow or red or blue. It's not just like any ordinary yellow or blue or red. And their spacing between them is also very significant. So when we see this pattern, we know that we're looking at argon. All right, so let's summarize just everything that we've been talking about for this last little bit here. We started out by looking at just a light bulb, and I showed you that if you take normal light and you divide it up, that you see that the white light that you see is actually made of a lot of different colors. Then we looked at that light that you are actually seeing is just one small little part of a rather larger spectrum called the electromagnetic spectrum. It's just the part of the spectrum that we can see, so it's called the visible spectrum. We learned how in that spectrum, if you change the wavelength of light, you change the type of light you have. If you have longer wavelengths in terms of color, then you'll have more oranges and reds. If you have more shorter wavelengths, then you'll have more, in terms of color, you'll have more blues and purples and things of that nature. Then I showed you, all right, so how can we actually apply this? Well, I showed you that if you take specific elements and if you energize them, if you heat them up, then those elements, they do give off a color, like how neons was this really bright orange color, but then argon's was this really purple pink color that it gave off. Then when we unpackaged those lights and we looked at it, we saw that they weren't made out of all the different colors, that they were actually made out of different distinct little lines of color. That the neon one had a lot of reds and oranges, but then it had a few little greens and even a few blues if you could look really, really close. Argon's, on the other hand, had a lot of different colors all across the spectrum. But all the same, again, they have just these distinct little barcode pattern lines. So let's tie all of this together and why this is all important and how this helps us. If I were to tell you that we know the sun is made out of hydrogen, or that we know other suns or stars are made out of hydrogen, or that some are burning more helium or some are made out of more oxygen, how do I know that? How could we actually say that we know that these stars are made out of these things if we never actually get to them? They're ridiculously hot. How can we go and actually sample them and find out what they are? It has to do with the light that they are giving off. When we look at these stars, just like what you and I did in this video with that little lens, when we look at these stars,
with certain spectrometers, they're called, you can actually see these distinct patterns for these elements come up. We can look at our sun and know that it's mostly made out of hydrogen because when we look at it, we can see that very distinct pattern of hydrogen lines in the sun spectrum that it gives off. When we look at other stars, we can tell that they're made out of oxygen or neon or other things because we see the very distinct pattern of those elements appear in the spectrum from those stars. So we can tell what a star is made out of without even having to go there. If we can see the light from that star, then we can actually find out what that star is made out of. And this is a very significant piece of information to know because, as we said, if we can change that spectrum, if we can change the wavelength, then you change what the light actually looks like. The spectrum that I was showing you for all those elements, they never change in terms of the pattern. Neon will always have that same amount of lines. Argon will always have that same amount of lines. But, like we're going to learn, you can change one particular aspect about it. And that's what we're going to look at next.